Hello, and welcome to Senior Code Review Buddy. My name is Chris, and today I'm going to talk about keeping your try except blocks as small and precise as possible, and why I think your code will benefit from that. A try except in Python is a fairly simple thing. You've got code that runs in the try block, and then you can add some error handling into the except block to catch exceptions that the try block throws. You get to decide how much code goes into the try block, what exceptions you want to catch, and how you want to handle those exceptions. Maybe you just print an error message, you load a backup file, or you re-raise the exception and terminate the run. It's up to you. But it can be kind of tricky at times to determine what code you should have in the try block and what exceptions you want to catch. In theory, you can run your whole program in a try block and catch every exception that is thrown. But that probably isn't very helpful. If you are covering your whole program and catching every exception, what do you do with the exceptions you catch? How do you know what to do? If you've got an exception where a file was missing on disk, you'd probably want to try and recover from that in a different manner than if the exception was a user input a float instead of an integer. So this kind of leads me to my suggested starting point. When you are catching exceptions, you probably want to have an idea of what you'll do if you catch it. If you don't know what you do if you catch it, why bother catching it? And if you know what you are going to do, then hopefully you know where that exception could get thrown from, and that should probably be the only section that you have in the try block. So for example, if we've got a function that queries a file on disk for input and then performs an operation on it, if we want to catch the exception when the file isn't present, we should just have that operating code in the try block. There's no need to have the code that is performing some operation on that input in the try block, since it shouldn't be throwing the file not found exception, and even if it was, we'd probably need to handle it differently because it probably isn't the same file. Alright, it's a bit tricky to talk about this in abstracts, so let's walk through some examples. Okay, for example 1, we've got a function here, execute query, and the whole body of the function is in the try block. But does it all need to be there? So looking at this, the exception we're catching is database connection error, which to me sounds like this should only come from connect to database. So if that's the case, I'd suggest moving run command out. Then in the except block, just return directly here so we don't try to execute a command if we fail. So this I think seems like a reasonable change. But what if the reason that we had run command in this try block was that it is possible for run command to throw a database connection error? Maybe, it tries to reconnect to the database, it connects to different databases. There are various reasons that it could also throw a database connection error. In that case, I still think it makes sense to pull it out from this try block, because I think that makes it easier to communicate to us what error is happening where. If we go back to how it was before, and it's just this one try block, if I get an exception here, because we're not printing the exception, which isn't a good practice, it just says failed to connect to database. So my first instinct is going to be, okay, so connect to database had an error, I need to fix that. But if the exception was thrown from run command, well, that's not actually the case. So we probably need to add better information here to explain which function is giving the error. So what I would do is I'd move this out to its own try block. And then print something like failed to connect to database when running command. So this makes it a little clearer that here it's an initial database connection error, and here it was a connection when we were trying to run the command. So I think this looks a little cleaner. Okay, let's go to example 2. All right, for this example, I want to show the dangers of sort of catching any exception instead of being very precise. So we've got a little function here that takes an amount of money in Canadian dollars and converts it to US dollars. We've got a couple of print statements here just to kind of test it. So if we run it, okay, so the first one, yep, the given amount must be a float. Q is not a float. But 1 given amount must be a float. Okay, 1 I guess technically isn't a float, but I would expect it to get converted. 1.0, given amount must be a float. Well, that's definitely a float. So something seems wrong here. Well, if we look at the function itself, we're catching exception, which is the base class of every exception. So we are catching every exception, and then we are just printing a hard-coded response. So if we had some other exception, we're kind of hiding it. So let's change the code here and actually print the exception and also print the type. We'll actually do the type. No, we'll do the type second. If we do that, okay, the first one, yeah, we get the value error. Oh, for these other two cases, we get a different error message. It's not about converting the string to a float. It's can't multiply sequence by non-int of type float. And it's a type error. Well, the problem here is that CAD to USD exchange rate is a string. Maybe I copied this from somewhere, put it in as a string instead of a float. So it should probably be a float, so let's try it again. All right, this works. So we correctly get an error in the first case, and then in our other two cases with values that can be converted to floats, everything works and we get the right value. So this is fixed, and we've added better documentation here to help people figure out the issues in the future. But I still think we should make a change here. We shouldn't be catching all exceptions because it wasn't quite right. Like, we were burying or hiding a error that we want to handle in a different way. Given that we're sort of intentionally trying to deal with cases here where the given amount must be a float, we probably only want to catch the errors that generate that. So we probably just want to catch a value error. And if we do that, okay, so we get the same results. This seems better. But also, where can the value error that we're thinking about come from? Well, it's just this part here when we're trying to cast cat amount by float. If convert was to give a value error from itself, that would be, our hard-coded string here probably isn't the right value. So we maybe want to change this as well and only have this cast in the block. So if we maybe change this to float amount, oops, and we'll do this, and we'll want to return a none now because we can't proceed if we don't get a value. Okay, and this gives us the correct results as before. And so I think this is better because we've been more precise in what kind of exception we want to catch and handle. And we've also sort of minimized the code we're covering under this block to where we're expecting to get an error and expecting to handle it. It's not to say that this couldn't generate a value error, but if this does, I think we want to be deliberate about, like, okay, we got a value error here. How do we want to handle and recover from it? Because if it's coming inside convert, but cat amount was a float, you don't want to tell the user that the given amount must be a float. That's just incorrect. All right, let's go to our third and final example for the day. So for my final example today, I've picked up some code from the official Python 3 documentation on errors and exceptions. So this function read file, I made a few changes to it. I moved it into a function so it's easier to write tests for. I added returning the value I. Also, so there's side effects, well, not side effects, but there's a result I can test for. And same with re-raising the exceptions here. But other than that, the rest of this code is from the documentation. Now, before I go into it and say sort of what I would do better here, I'm not trying to say the Python 3 documentation is wrong or bad, because often in documentation you're trying to explain certain things. So they maybe did some things here because they want to show a certain feature of the language or how a certain thing went, and it can be useful for that. But I also think a lot of people trying to learn Python might look at the docs and they might say, oh, this is how I handle exceptions. So they might just copy paste that code. And then if there's things that they shouldn't be doing in production there because it was more a documentation thing, it maybe comes over. So that's why I do think it is still worth looking at this and talking about how this could be made better. So to start, I added myself 3 tests looking at sort of the 3 different cases that I think this code could run into. So we've got no file present. The file is present, but it's not an integer as the first value. And the file is present, and readline does return an integer. All right, so let's run it. And yeah, we get OK, ran 3 tests. So that's good. But we can also see Python is a little unhappy because we are not, unclosed file. Yeah, if we look here, we aren't ever closing this. So let's change this to use a with. So it will close itself automatically. Rerun. And there we go. So we've got all the tests passing, and Python is happy because we are closing all the files. Now, as I mentioned, I have 3 test cases, 1 successful and 2 that end in exceptions. But if we look at the code itself, there's 3 exceptions getting caught here, but I'm only testing for 1. We've got a test for OS error, we've got a test for value error, we don't have test for exception. And I'm not sure right now how I could sort of normally get a just exception to come out of this, only changing sort of file path or what the file contains. So I don't think this actually makes much sense. And if we look at the code here too, all it does is print the error and re-raise the error. So this doesn't seem particularly helpful. So what I'm actually going to do is I'm going to say in this case, we should just have it removed. If we don't have a good reason for catching an exception, we don't sort of know how to recover from it, it's probably not too helpful. So if we take that out, we rerun, yep, all of the tests still pass, which is good. All right, so now we've got all the code in one try block with 2 exceptions. I think this OS error can only come from this open file line, and I think the value error can only come from this int cast. So instead of having 1 block that covers all of this, let's split it into 2. So we'll take this, and we'll make that. Okay, so let's try to run that. All right, so it runs and it works. So I think this is easier to read because it's clearly documented where we are expecting each type of exception to come from. And if an exception comes from a spot we aren't expecting, for example, this casts OS error, then we probably want to catch it because it's like, oh, this is a different OS error from this one. We probably want to handle it differently. Same with value error. If value error suddenly came from open, it wouldn't make sense to say couldn't convert the data to an integer. It's a different kind of value error. So we won't accidentally catch stuff. So all of our tests pass. I think this example is a little cleaner, and it's maybe less suited for describing the behavior of the Python docs we're trying to use it for, but I think this is probably better code if someone wants to copy and paste it somewhere. So that's a few small examples of how I think you can better handle your exception code in Python. So hopefully the next time you're writing exception code, you're able to make it a little bit cleaner and easier to use than before. Do you have any tips or tricks on how you would deal with exceptions in Python that I didn't mention? If so, please leave a comment down below. If you enjoyed this video, please consider hitting the like button below and subscribing. It really helps me out. If you have any other comments, code you'd like me to review, or ideas you'd like me to talk about, please leave a comment below or reach me at chris@seniorcodereviewbuddy.com. Thanks, and have a great day.